Yes, I want to start with a picture which shows the SDGs, but it puts a special emphasis on the interconnections that combine the SDGs. So the concept itself claims to be integrated and indivisible, which means that you should not try to reach one goal without considering what has happened to other goals. And in my master thesis, I was interested in what does this mean when we implement energy and carbon taxes? How do these taxes interact in this system of the SDGs, and what effects would we expect therefore? So the research question of my master thesis was, how does the introduction of energy and carbon taxes influence the energy system and the progress towards achieving the SDGs in Austria from a systems perspective? So I was not only interested in what is happening to the energy system, but also what is happening to other SDGs and other indicators. And to obtain a systems perspective, I approached my research question with system dynamics modeling. System dynamics models are built on stock and flow dynamics. They incorporate delay mechanisms, and they are rich in its feedback structure. And the overall purpose of such models is to understand the behavior of a system. And therefore, I applied the ISDG Austria model. It's a quantitative simulation model, and it consists of social, environmental, and economic sectors, and therefore it combines multiple indicators from the SDG concept. Therefore, I analyzed 3 different scenarios and compared them to a baseline scenario where no policy intervention have yet been introduced. In the first scenario, I implemented just an energy tax on the consumption of oil, gas, coal, and electricity. In the second and third scenarios, I additionally also implemented a CO2 tax at a rate of 250 euros per ton CO2, and in the second case at a linearly increasing rate from 50 to 250 euros per ton CO2 in 20 years. And overall, the tax revenues do not have a specific purpose. They are just going into the government budget. So in the energy sector, one result we would expect is the share of renewable energy to increase. This is due to rising prices for fossil energy and also due to a decrease in energy consumption as energy as a whole gets more expensive. And here you can see the actual results from the model. In a baseline scenario, which is the line in blue, the renewable share would be slowly increasing, and this can be it would be stronger if we would implement taxes, especially energy, especially carbon taxes. And in the electricity generation sector, the results were a bit surprising. So in a baseline scenario, the share of electricity from renewable sources would be decreasing, and this can only be prevented with carbon taxes, but also the level of 2020 would be just constant. Yeah. Then besides the energy sector, I also looked at what is happening to economic indicators, for example, the real gross domestic product. And it was quite surprising that nothing really happens to this indicator, and this can be mainly traced back to the tax revenues that are not earmarked in the model. Yeah, finally, also the environmental impacts were some results to my analysis. So here we would expect from the rise in fossil energy prices and the consumption of fossil energy to decrease, and therefore the greenhouse gas emissions would also be decreased, as well as the air pollution. And both effects can be seen in the model. So first, the greenhouse gas emissions in the baseline scenario, they are projected to be steadily increasing, and this can only be prevented by a carbon tax, where you can see that the emissions would be decreasing after 2020. And a similar picture is shown for the emissions of particulate matter, which can be seen as an indicator for health or the air quality in cities. And yeah, the same can be seen here. In a baseline scenario, we have a steady increase, and all 3 tax scenarios have lower levels of air pollution. Now I will turn to 2 conclusions and also some improvements. So first, the model captures quite nicely the multiple interaction effects that are caused by a tax introduction. So the feedback structure of the model allows to assess what is happening to SDGs from the economic sector, from the environmental sector, and so on. And however, the delays that are incorporated in the model impede far-reaching changes. For example, in the electricity stock sector, we see that we have locked-in effects and that electricity generation stock that we have built up until the tax is introduced persists. Yeah, finally, one improvement I would add for better results. So in the transport sector, we have two missing links. So the final energy, the fuel prices do not impact the share of electric vehicles and also not the motor fuel demand. And finally, also social indicators would need to be added for more comprehensive results. This would include to be able to analyze what is happening to inequality or what is happening to energy poverty. Yes, and finally, I want to point out two further research topics or research questions that would be interesting. So from the literature, we know that the interaction effects or the final effect of a policy intervention crucially depend on the one hand side on the policy design, but also on the interactions with other policies. And in my case, therefore, it would be interesting to see what is happening to the results if we introduce revenue recycling schemes, an expansion of public transport, subsidies for refurbishment, or, for example, a ban on fossil heating systems. And all these policies would interact with the energy and carbon tax introduction, and therefore the results would be crucially depending on these interactions. Yes. Thank you.